All right, here's our fourth example. I look at this one and I say, oh, I remember this way back from Unit 1. I've got to use the substitution method. So I choose any letter as long as it's not a letter that's in the original equation and say, let that letter equal what's in the quantity r plus 3. So now I'm going to rewrite this as 5x squared plus 9x equals 2. Well, this still isn't in standard form. I need to subtract the 2. And now it's in standard form. So now I need to choose my method. Once again, it's not in the proper format to use the square root property method, so I'm not even going to. And it didn't tell me I had to, so I'm not even going to worry about that. So I'm going to see if I can factor it. 5 times 2 is 10. 1 and 10, 2 and 5. Maybe if I do a negative 1 and a positive 10, when I add those two together, I get a positive 9. Negative times a positive is negative. So it looks like I can just factor this guy. Let's see. We'll do plus 10 minus x minus 2 equals 0. Now I'm going to factor by grouping. So I can factor a 5x out. That leaves me with x plus 2. Factor a negative out. That's all I can do, but it does change both of my signs. So I get x plus 2 equals 0. Then I get x plus 2. 5x minus 1 equals 0. X plus 2 equals 0. 5x minus 1 equals 0. X equals, negative 2. And x equals 1/5. I did skip a step there, so look it over, make sure you get it before you go on. Now remember, I'm looking for r plus 3, not x. So wherever I've got r plus 3, I've got to put it back in. Well, each of these actually. So r plus 3 equals negative 2. So r equals negative 5. And r plus 3 equals 1/5. So r equals negative 3 plus 1/5. And now I need a common denominator, which is 5. And so r equals, if I multiply the denominator here, 1 times 5 is 5. If I do that in the numerator as well, which I have to, negative 3 times 5 is 15. Plus 1 over 5, r equals negative 14/5. And so I get r equals negative 5 or negative 14/5. If we have time, I'll come back and do this one as a quadratic formula, or in the quadratic formula. 1, 2, 3, 4. So 4m to the 4th equals 3m squared plus 1. So 4m to the 4th minus 3m squared minus 1 equals 0. Now it's in standard form. I can go ahead and decide which method I want to do. So 1 is 4, 1 and 4, 2 and 2. Maybe I can make that work. So that would be positive 1 and negative 4. When I add those two together, I get negative 3. Positive times a negative is negative, so that's going to work. So I can factor these. Very cool. 4m squared plus m squared minus 1 equals 0. Factor by grouping. That's going to leave me with 2m squared minus 1 plus, no it's not, yes it is, hang on. I see where I messed up, because this is not going to be 2m squared, it's going to be just m squared. And then I'm left with m squared minus 1 here equals 0. So then I get m squared minus 1. 4m squared plus 1 equals 0. Ooh, look! Difference of squares! M plus 1, m minus 1, and 4m. This is not a difference of squares because it's a positive. So now I'm going to set each of these equal to 0. And 4m squared plus 1 equals 0. So I have to bring in everything I've been doing all semester long into these problems. So now I get m squared equals negative 1 over 4. Now I need to plus or minus the square root of negative 1 over the square root of 4. So that's m equals plus or minus I over 2. So my final answer equals plus or minus I over 2 or plus or minus 1. Okay? I want to do 1, 2, 3, 4, 5. Let's do, oops, let's bring it down just a little bit. Number 6. Okay, let's look at this one. It looks a lot like the one we had before, the second one, except that the radical is only over the x. So I need to get that radical term all by itself before I can start. Okay, so now I'm going to square this. If I do that on one side, I have to do it on the other, but I have to square everything. And look at this, guys, perfect square trinomial. So 2x squared is 4x squared minus 2x times 1 is 2 times 2 is 4x, and then plus 1 squared is 1, and then I've got x over here. So I need to get it into standard form. 5x plus 1 equals 0. And now let's see if I can factor it. Yeah, let's do I could probably factor this, but just for fun, let's do the quadratic formula. And c equals 1. So x equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So we get x equals 5 plus or minus square root of 25 minus 16 over 8. X equals 5 plus or minus the square root of 9 over 8. X equals 5 plus or minus 3 over 8. Split this out. 5 plus 3 over 8. X equals 5 minus 3 over 8. This is x equals 8 over 8, so x equals 1. This one is x equals 2 over 8, so x equals 1/4. But remember, it was a radical, so I've got to check these answers. So let's check this one. X equals 1. We had 2x equals the square root of x plus 1. So 2 times 1 is 2. The square root of 1 is 1. And 1 plus 1 is 1. So that one works. Let's check this guy. X equals 1/4. So we've got 2 times 1/4 equals the square root of 1/4 plus 1. So this is like over 1, so 2 goes into itself once. So we've got 1/2 equals, and if I take this as the square root of 1 over the square root of 4, square root of 1 is 1, square root of 4 is 2, plus 1, well, that would be 2 over 2. And so this ends up being 1/2 equals 3/2. So this guy doesn't work. So my only answer is x equals 1. Now it looks like I might have enough time. Let's go back and look at this one, number 4, where I did the substitution. So I'm going to take from here. We already know how to get here. So 5x squared plus 9x. What is this one? Number 4. So 4. 5x squared. I should have written this down. Plus 9x minus 2. Plus 9x minus 2 equals 0. So I'm going to do this one in the quadratic formula. We already did it once by factoring it, but let's do it as the quadratic formula. -2. So x equals -b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay, so x equals -9 plus or minus 81 plus 4 times 5 is 20 times 2 is 40 over 10. X equals -9 plus or minus, and what is that? 81 minus 40 is 41. Feels weird. What did we get up here for an answer? Is this it? Nope. Well, I don't want to take up time. I've messed it up. I will go back and try it again and show you in class. But there you go. Lots of different examples for just how to do any of these things. Okay?